I mean, you're a real astrophysicist. I still have a few months left on my PhD, so I'm not quite there.
Closer than I am.
I mean, anyone that's thinking about it, I think that counts. No gatekeeping.
It's always nice to hear that because as a radio astronomer, I feel like there's so much gatekeeping that's like you're not a real astronomer. You deal with voltages. Like, give me photons.
Yeah, but voltages and stuff coming from where?
Space.
Dang!
It's all
Thank
photons.
you.
It's photons.
Everything comes from space sooner or later. Or if you go back far enough, rather, not sooner or later. Everything goes back to space sooner or later.
Yes. Ooh. Star stuff becoming star
One
stuff.
way or another,
That's it. We're going out there somehow.
whether you like it or not.
I love it. I love that we finally, right, have a UV astronomer joining us on the show. So
It is a wildly neglected wavelength range, so I'm not surprised. I'm disappointed, but I'm happy to be
Really?
here. There's not that many of us.
we were talking about it a few episodes ago, maybe last season, and like I had not realized the fact that radio astronomy was the first non-optical astronomy to be developed, and then I don't remember if it was our guest or Benjamin who had just said, well, no, duh, because like you have to launch stuff into the stratosphere or into space to do any other sort of non-optical astronomy. So yeah, it's pretty wild what you guys do. Amazing. We have today a wonderful, wonderful guest, Professor Erika Hamden, joining us all the way from Arizona. You are an astrophysicist, a science communicator, a designer of space missions. I'm sure, like, I don't have enough fingers to count all the
And a
things.
chef.
And a chef.
Oh, yeah.
Yes.
I was watching a TED Talk. She gives TED Talk. And I'm like, what? Also a chef?
I contain multitudes.
I definitely noticed that. Just like going through various CVs or socials or Wikipedia. You have a Wikipedia page as well, and just seeing like a casual, culinary course at Cordon Bleu. Okay.
No, that's the other life path. Like, oh, maybe I became a chef in a different version of the universe.
Oh, that's deep.
Yeah, but still cooking up hydrogen, measuring experiments, which is.
So there's another universe where she's like this awesome chef, but she took a break for a second to build a satellite real quick. And
yeah, just one chef on the side.
Just a little bit.
The universe sounds great.
I'm like, yeah, in awe of everything that you have done to now, and like you continue to do amazing things. And we'll come back to your book later in the episode. But you have just written a book, Weird Science, which Benjamin is holding
Weird
up.
Universe.
Weird Universe.
Mine's got notes.
I don't have a. But yeah, how do you find the time to balance all of this stuff?
I don't know. My parents joke actually that I have a clone that works at night while I'm sleeping, and like so they ask if daytime Erika or nighttime Erika did it. But for the book anyway, I wrote it a little bit. I took some time off last summer and was on a cruise with my mom, so I like wrote it on the cruise, and then I would write it on weekends and like in the evening. It was kind of a nice. Once I like got into a groove with it, it was like fun to go to because it's extremely not technical and it was fun to like look up stuff and like find these old papers about things and but I actually I think I'm just a very efficient and I also am like not a perfectionist about things like and I've been this way for a really long time. Like I remember in college, I would be like, "Yeah, this problem set's good enough. I'm going to bed," and everyone would keep working on it, and like I would just turn it in as it was at 11 p.m. because I had to go to sleep, and we would get like the same grade. Sometimes my grade would be a little better, so like it's fine.
It's such an important lesson that I feel like I didn't learn until like the last year of undergrad, after burning out I think Thursday nights were our submission deadlines, and it was
Yeah.
exactly that. It's like working down to the last second, and ultimately you're just like tiring yourself out. You're not actually getting better grades.
Making it better. Yeah.
Yeah.
So I learned really early to just be like, oh, this is fine. If someone doesn't like it, they'll tell me. And then I just go on to the next thing. And I guess I like challenges. I like learning new things. So I'm always kind of willing to be like, okay, let's just do it and see what happens.
Nice.
And that's why I do the thing I do. I'm constantly just assigning myself homework, and I just turn it into little things I can present on Science Actually, like little knowledge nuggets every day. Like, that's how I ended my day yesterday. I learned something, and now I'm sharing it.
Fun.
That's all I do. That's why that's how I found you on TikTok. Like, here's another person doing another little knowledge nugget every day. Like, this is the exact bite size that I need to ingest this more new nuggets of information. It makes me so happy.
Yeah.
Like, oh, there's more people,
Bite-sized
just like science.
Bite-sized science is good. Yeah. And like, I think people need stuff that's like, science is fun, science is amazing. Like, this is not gonna make you feel bad. This is just gonna be like a cool thing that we know. And maybe it'll encourage you to like learn a little more on your own.
I think that's so important, because the framing that a lot of people have from high school is this idea of like, oh, you must memorize these facts. You don't care about them, but you must memorize them because they're important. Yeah. And some people just develop this aversion to learning, or even just to the word science. It gives them the ick, because they're like, oh, no. And once you can get past that, if you can get past that and just recognize like the beauty in learning fantastical things about the universe, there's so much to be gained. And I just think I have a much more like romantic view of science, because I came to science later in life. The thing that I wanted to ask then was, what was the rationale behind the choice of starting your book with a section on like the hardest thing to explain?
Because that's how it's viewed, as like, oh, so the first chapter of the book is about space-time and like relativity, and chapter 1, space-time, the counterintuitive fabric of the universe. And when I wrote it, it was actually in a different order. Like, a lot of astronomy books and books about space are like, oh, we'll start with the solar system, and then we'll talk about stars, and then we'll talk about galaxies, and then at the end it's like space-time, black holes, dark matter, dark energy, like all the wacky stuff. And so that's sort of how I wrote it. And then I realized like, well, what I try to do with my social media videos and what I want to do with the book is, I believe that anybody can learn anything if they're given like the right instruction and they have the time and the space, like space, the time and the space to actually like get into something. Of course, they have to want to learn it, but like I think that so much of what society tells us like people can and can't do is really just like circumstantial and not like an innate ability. And my view is like, well, if a person understood this, then any person can understand it. And so I try to take that approach by being like, okay, I'm going to throw, and maybe this will turn people off. They'll open the page and be like, oh no, this is going to be too hard. But I want them to actually realize like, oh, if things are explained carefully using like analogies that you can understand on Earth, and if you're willing to just like give it a try, then you can have some understanding of space-time. And I like to tell people about it, because it's like, that's how Einstein came up with it. Was not like, oh, let me write down a bunch of math and like work through it. He came up with it by thinking about like people in trains, like traveling, and like what happens when they turn a light on or when they like throw a ball or whatever. And so that like framework, which was good enough for him to come up with it, and then he like kind of worked on the math to explain it. Like that framework, I think, is a great way to teach it, because that's actually like it's the way that people think.
Yeah, I guess there's a difference between like people think about making science accessible, and that doesn't just mean like, here you have access to the internet. It's making it kind of like intellectually accessible? Like,
Yeah.
is it in the language that you can relate to? Yeah, I love that.
And like, can you read this and not get caught up in like parsing the sentence, but actually just like think about what the point is? And the way that you actually described it is like, I am lightly obsessed with this woman, Emily Wilson, who does Greek translations of like ancient Greek works. So she's became well known, like I guess 8 years ago, for doing the first. She was the first woman to do an English translation of the Odyssey, and then
Oh wow.
her translation of the Iliad came out a couple years ago. I think she's a professor in Pennsylvania. But anyway, her translations are very controversial because she writes them in like modern English vernacular. And a lot of these translations of like ancient works are very like heightened, as if it's like, oh, this is fancy, so like all the words have to be fancy. And her interpretation is like, no, like this was supposed to be entertainment for like regular people when the traveling bard would like come to the village, and so it has to be in like a language for regular people.
Yeah.
And that means you can just read it like, oh, like, oh my god, all this stuff is happening. It's like exciting and engaging because you're not like also thinking about the process of reading it. And that's what I think that more science should be, where it's like, how do you convey these issues to a person who doesn't have the like complicated language, and if you use it they get caught up in it, but I think you can still explain things to them.
Cool.
I have a book.
The translations are really good. If any of you are interested, like I read the Iliad one like this in the last 6 months, and like the 23rd chapter out of 24 chapters, like after Troy has fallen, they're like, now we're going to have a bunch of sports events. Like there's going to be a foot race. There's going to be like spear throwing. Like the whole chapter is just about this like sporting event that they put on. And and I was like, oh, I don't think I've ever made it this far in the book.
I didn't even know it was in there.
I didn't know that happened.
Spoiler alert for a 2,000-year-old book.
Yeah. Troy Falls, guys.
Makes you wonder how many people over 2,000 years actually read the whole thing.
Yeah,
Even back
like,
when
oh,
it
they
was
made it. They're like, you guys
language.
might get bored, so we're gonna put some like some sporting events in here so that you'll be excited again.
That's awesome. All right, where to next?
I mean, yeah, Benjamin, I know that you had a lot of questions prepared because as you were doing preparation for this episode, you just kept finding more things that were like, oh, wow, oh, that's amazing. Oh, my God, wow, are we having a celebrity on the show? It's like...
Well, yeah. I mean, like I explained earlier, I first came across your content on TikTok, Instagram, whatever, when it's on the social medias. And I'm like, this is fantastic, and I love it. And I've even used some of the things that you've posted as a science fact, and I'm like, oh, I'm going to use that as my daily science fact because I just learned it, and I made sure that, and I wrote thanks to Erika Hamden on it because it's not me. And I'm like, oh, this is fantastic, and so I would be great if she was on our show. This would be awesome. And then reached out and I said, yeah. Like, oh, I'm learning that about our little science communications communities, that you just reach out and say, hey, you want to have a chat? And usually the answer is like, yeah, why wouldn't I want to have a chat?
Yeah, I love a chat.
It's fantastic. First and foremost, how many pairs of glasses do you own?
I have, I think 12 pairs right now. And I guess I did just get a new pair that are it's like in my bag at the front, but I'm like getting old and my eyeball shape is changing, and I like need a different pair of glasses for when I'm working on the computer, because it's like I'm nearsighted, so these are so that I can see things far away. But like now it's getting to the point where sometimes when things are close, I'm like, oh, it's easier if I take my glasses off, and then I just feel like so old. So I guess I have 13 as of like last week.
Right on.
But before that, my prescription had been the same since I was like 15. So some of the glasses are old. I just like am able to keep wearing them. So that's partly why I have so many of them. And it's the only accessory that I like. Like I don't wear jewelry. I don't like belts or anything. It's like just the glasses.
Cool.
I'm like so new to the glasses game. I had actually tried to fail an eye test on purpose when I was a kid because I thought glasses were cool. And the optometrist saw right through it. But yeah, I've had these bad boys for like 6 months, maybe closer to a year, and I'm still getting used to like all of the standard stereotypes of like, oh, gotta fix it, gotta clean it, like.
Yes.
Does
Yeah,
give
you can
me,
like,
yeah.
I
there's a
love
lot of
doing
like
that.
good.
Oh, really? You're going to approximate G is 10? Really? Is that?
Oh, the takeoff. I
Yeah.
love doing the takeoff. My head's too
Yes.
big, so it doesn't work really well.
There's
Oh,
there's a guy, I forget what his Instagram account is, where he like does these silly videos, and then if he gets really excited about something, he like takes his glasses off and throws them across the room, and then picks up an identical pair of glasses and puts them back on.
oh God, that's funny.
It feels like a Hank Green thing to do. Nice. I'm very curious. Like, what was the thing that made you dive in? Speaking of vision, not to optical astronomy, but like UV astronomy and this fascination that you have, or if I can say, obsession that you have with hydrogen. Like, how
Yeah.
did you hone in?
So it's a little bit of like by accident. Like I knew, so I went to undergrad and got a like degree in astrophysics, and I knew that I liked doing research, and I like, I worked as a chef to see like the other career path that I was interested in, and I felt like, oh, I want to like use my brain more. So I went to grad school, and when I went to grad school, I knew that I wanted to build things. Like part of what I like about cooking and the what I like about my like space mission stuff is like I like to create a physical object and to be like, oh look, I put this time in, and then here's this thing that I made. And I don't want the thing to just be like an array of numbers on a screen or like a simulation. Like I want the thing to be like three-dimensional out in the world. And so I knew when I went to grad school that I wanted to work on instrumentation and like building components for
Hmm.
telescopes or whatever. And I also knew that I liked cities, so I wanted to live in New York. So I went to Columbia. And so at Columbia, there were a few professors who were doing instrument related work. And the one that I liked the most happened to be an expert in the ultraviolet, one of like the very few people who was an expert in the ultraviolet. And so that was what started me in that like kind of regime. And I started by doing some detector technology development. And I'm still really involved in detectors. And like two of my students have different detector development projects. And then I realized, like after I had been doing it for a little while, that like the ultraviolet was really underexplored and like underutilized. And David, my advisor, like we talked about why that was, and like apparently there was a feud. This is the stupidest reason. There was like a feud in the 60s between the two students of some professor at Berkeley, and the students hated each other. And those two students, like one went to University of Colorado and the other went to Caltech, and like they would like I don't even know why they hated each other, but anyway, it caused this huge rift in a community that was only like 6 people large. And so you have to get money from NASA to build your telescopes because you can't do ultraviolet astronomy from the ground. And so because the community was like so bifurcated, they like couldn't come together to do anything or to like out motivate other wavelengths or other science topics. And so there was this like weird personality issue, and only now in the last like 15 years has enough time passed that the like students of those people are like, we don't care about this anymore.
Oh my God.
Yeah, but so because there was this gap in like we haven't even looked at all parts of the sky in the ultraviolet. Like that's how underexplored it is. Like I give a talk where I show people pictures of the Orion Nebula cluster, like the sword in Orion's belt where there's these huge new stars being formed. It's like a super interesting place. It's like massive amounts of star formation happening very close to us. It's only I think it's like 1,000 light years away from us. And we have pictures in the infrared, we have pictures in the visible, we have pictures in the X-ray. There's no picture in the ultraviolet, even though the stars are brightest in the ultraviolet, and there's like a ton of information in the ultraviolet. We're just like, well, what if we didn't look at it? So then I realized like, oh, this is an opportunity, and modern academia is so competitive that I felt like, okay, if I have this niche and I work in a field that not many people work in, and if I can do this technical work that not many people can do, then that will make it easier for me to get a job. And it just helps that I also like it a lot. And then as I like kind of developed as a scientist, I got more interested in not just like the hardware, but in like, why are we looking at things? And I realized like, for me, I like I'm obsessed with hydrogen because I want to know about how things form. Like I like a galaxy, I like a star, but I'm interested in how it goes from being this like amorphous blob of hydrogen into this like highly ordered and beautiful structure. And you know, we have these like kind of large scale stories that we tell about like, oh, the cloud collapses and forms a star. Or you know, the material conglomerates and eventually a galaxy forms, but actually all the like nitty gritty little details in the story are like, we don't really know. And so that's the part that is compelling to me. That is this like such a, like the hydrogen is everything. And, you know, we know that it is everywhere, but then like how it actually gets into these structures, what is required, why do you have certain regions like Orion that are forming stars, and then other areas that have hydrogen, but something about them is different, and so they're not forming stars, and we don't know exactly why. So like I like the kind of precursor to the thing, and in the universe, that's hydrogen is always the precursor.
I love that. And I feel like there's maybe a bit of crossover with radio there, because a lot of people use radio astronomy to study like H2
Neutral
regions.
hydrogen.
And
yeah.
It's super cool. And I'm just like thinking back to like the undergrad cosmology courses that I took, and like the stories that we tell ourselves of like, okay, so there's like a clump of hydrogen and it collapses into a Zeldovich pancake. And you're like, why are we talking about pancakes now? It's like, no, this is the conceptual framework that we have to use. Because otherwise we have no idea what's going on.
Yeah. And I think, and there's so many other, like, as I've learned more, you know, there's so much more information in the ultraviolet that we're just kind of leaving behind because we don't have a good ability to observe it, you know, related to like how stars explode, the like very early life of big stars, and all sorts of kind of chemical elements have like excellent signatures in the ultraviolet. So I'm always like, when I give talks, I'm always like telling people like, if you're looking for new things to do, like propose a UV telescope, because I sort of feel like I try to have like an abundance mindset of like, other people succeeding doesn't take away from me, and what I really want is for us to understand more. And so the more people that I can get into the field, then the more money there'll be, the more work there'll be, the more discoveries there'll be, and that's what I actually want.
Cool. Yeah, I like that mindset. Benjamin's furiously taking notes.
Sorry. I just think that's what I do. I take notes. Ask Kavi. I take notes like crazy.
Yeah, honestly, like the prep that Benjamin does for these episodes is like, his notes are
Extensive.
Yeah, extensive.
Sorry.
No, nothing to be sorry about.
Anyways, moving along. Can we ask about the Fireball telescope and how incredible that was? I mean, I watched the. I know it's a hard. So many starts and stops, and I read that you're going to try another one soon.
So
is it happening?
So
is there going to be another one?
There's not going to be another one. Spoiler alert. R.I.P. to a legend. So Fireball, for people that haven't watched the talk, is a.
Sorry if I didn't mean to touch a nerve. Or
no, it's okay.
But it's a beautiful thing.
Yeah, it's a telescope that I helped build that flies on a high altitude balloon. So it's like very wacky as a telescope, and that I've like had so many crazy hijinks related to it, just from like, because we launched them from this remote part of New Mexico, and you have to have like the weather cooperating, and like it's just like a very intense experience. And we launched the telescope in 2018. And I gave a TED talk about it. And I was like, originally the plan for the talk was to be like, look at all this stuff we discovered. It was designed to look for hydrogen around like moderately distant galaxies. And so my plan for the talk originally had been to be like, oh, we built this telescope, it flies on a balloon, isn't that wacky? And then like, here's what we discovered. And then we had the flight, and the balloon had a hole in it. And so the so we didn't actually get any data. And so the talk ended up being about like, how does anyone do anything? And like, you know, the process of science and discovery is actually really a process of failing, and then you get up the next day and like do it again and do it differently and do it better. And so we launched in 2018. The balloon had a hole in it. I had said in that talk that we would launch again in 2020, because it takes a little while to like turn it around. You have to realign stuff, and a couple of components broke. And then COVID happened, and so we didn't actually launch until 2023. And in 2023, the balloon had another hole in it that was actually bigger than the hole that it had in 2018. And I'm like, by then I wasn't running the project, but I had like, I was like leading just like the optical alignment and some subcomponents. And so I was there, but I was there that day, like running the project, because the project manager had to leave for like a family emergency. So I had like taken it over in 2023 again. And then the NASA people were like, oh, there's a hole in the balloon. And I was like, I'm having a stress dream. Like, this isn't really happening.
Can't be real.
It was like, this is exactly the same thing. But it was like worse. So they had to cut the balloon down earlier. It was just like, oh, it was so bad. And I was really sad because I had put so much energy into this project, and then to feel like, okay, this really isn't working. And we, you know, as a team, we got together and we're trying to figure out, like, is there a better way of doing this? So that's partly why we're not going to try again with the same telescope, because, you know, when the program was first started was ages ago. And between now and then, like, so much technology development has happened, not related to telescope, but just related to like getting things into space. It's like so much easier to put small satellites into space, to put small telescopes into space. And so the work that the like science that we want to do with Fireball, like now there are other platforms that you could do it on. Whereas when Fireball was proposed, the only way to do what we wanted to do was to put it on a balloon. And so we're with like a group of us, we're exploring like different ways to kind of do the same science. And some options, like some of the stuff we've been talking about is doing it on a balloon, but maybe a smaller kind of payload, something that's easier, or doing it on like a small sat, a CubeSat type thing. And the cost of that has just come down so much that it's definitely worth exploring. So that's where we are. It's funny because, like, you know, I was sad about the end of the project, but at the same time, the thing that I love the most about it was really the other people that we were on the team. And so all of those people were I still work with them. I'm still talking to them. And so it's still fun. It's just going to take a different form.
Nice. Yeah. I have a friend who worked on the Superbit telescope, which is also like a balloon-based telescope. And it's like a similar story of just like, I don't want to say drama, but just like it's really tough to do, and it's starting from often a place of like, well, maybe it would be simpler and cheaper if we didn't try to launch it into space, and then ultimately you end up at a point of kind of wishing that maybe that would have been the easier, more streamlined option. It's super tough, but it would be really cool to see more UV CubeSats or microsats or nanosats. I don't know where we're up to these days, but.
All levels.
Definitely need more UV. All the sats.
And I think that, like, I mean, the experience of working on Fireball was super valuable, and I learned so much about like kind of mission architecture, I think is how I would phrase it, of like why, like if you're trying to make an observation, there's many ways to do it, and thinking about what's the most efficient way to design your optical system, like what's the best type of detector to select from like a power or a cooling perspective, or like efficiency. And so I feel like I learned a lot of like the right way to do things and the wrong way or the less efficient way to do things from working on Fireball, and just kind of seeing in the field, like what were the components or the systems that were just like so annoying to get right, and how could I make something in the future that is less dependent on those really complex systems.
That's cool. Maybe Maybe just for our listeners slash viewers, besides hydrogen, like what are the things that we can see? Like why do we want to look at the universe through this ultraviolet lens?
So,
Just a question you get asked all the time.
yeah, I have
Well,
I'm
it's
like, oh, I have
brighter.
like a whole presentation about this. um, so basically, the ultraviolet is a really good tracer of a lot of like energetic processes. So when new stars form, they're really bright in the UV. The most massive stars put out most of their photons in the UV. And so if you're looking at a galaxy, you want to know, oh, how many stars did it make in the last million years? You look at the ultraviolet signature, and that tells you like the newest of new stars. If you look in other wavelengths, you're really looking at older stars, because all those really big UV bright stars, they explode in like 10 million years. So it gives you like this sense of the instantaneous kind of star formation. So that's like the beginning of life of the star. And actually, those really big stars, they're way more kind of impactful to the life of the galaxy than the average size star, because they're putting out so much energy that they destroy the cloud that they're born in. They like disperse the molecular cloud that forms stars, so they can turn the star formation off after. It's kind of like rude of them, like they've been born and then they're like, nobody else gets to form here. I'm going to destroy.
Pulling up the ladder behind them.
Yes. And they also put out these huge winds, which actually can like blow holes in the galaxy that they form in, and they can, you could also imagine, like, let's say that you are like a sun-like star that is forming, and one of these huge, massive stars is in the neighborhood. The disk of planet-forming material that might be forming around your sun-like star is going to get eroded from the outside by this huge, bright star that's like not that far away. And so the stars themselves can like change what happens in newly formed solar systems depending on like how close, like what the kind of energy environment of the neighborhood is. And so we think that they're actually pretty important in a lot of processes, like on the scale of galaxies, but also on the scale of like stars and the planets that those stars are able to form.
I was going to ask how big this neighborhood is.
It's
Sorry,
probably like tens to 100 light years that they kind of are dispersing things. Maybe a little larger than that. I'd say like 100 light years. And then they explode, and then in the explosion, they also put out a ton of UV light. So the explosion itself is like UV bright initially, and then over time, the like remnant will cool off, and then it emits more in the visible, and then it emits more in the infrared. But that initial like 2 days of explosion is like the UV is actually really important. If you observe the spectrum in the UV, you can actually figure out like what material is the star exploding into, like how much iron is there, how much carbon, how much oxygen, like actual abundances. And that's also true so when two neutron stars merge, that's when you get like all the good elements like gold and platinum and uranium, all these like R process elements that they form in these very extreme mergers that cause a huge supernova explosion. And the one that went off in 2017, that was what LIGO, the Gravitational Wave Observatory, like captured the first neutron star merger that we had ever seen. It was brightest in the UV for the first like 2 days, and then it cools. And if we had a UV telescope that could look with a high resolution spectrum, you could like see like what's all the stuff that is actually being made. And
That's crazy.
And so we don't have that. Like Hubble looked at it, but only after 5.5 days, because Hubble can't like slew very quickly to objects. But so that's just like what you learn from the star, like the birth of the star, the death of the star. The kind of interstellar medium, the stuff in between stars, has UV signatures of hydrogen, molecular hydrogen, and then a bunch of other elements, carbon, oxygen, silicon, iron, magnesium, just like all the things that you
All the
need.
good stuff.
Does a body good. And there's also really, like, if you're looking at planets, like, and you want to know more about the habitability of a planet, the UV is also very valuable. So like if you observe a star and you say like, oh, this star has an Earth mass planet in the habitable zone around the star, you might be like, oh, great, there's going to be life there. But if the star itself is very variable, like we've discovered, so our sun is actually a pretty chill star, but we've discovered that there are stars that put out these huge ultraviolet flares. Like, sometimes it's pretty frequent. Sometimes it's like, oh, they do a flare every like 10 years or 100 years. And so if you have a star that is a UV flaring star, it'll just cook the planet. Like, if it's sending out
strip
these
the atmosphere.
Yeah, I mean, it would get like 1,000 times brighter or 10,000 times brighter. So it's just this like crazy flare that happens that will destroy the atmosphere of the planet, and basically sterilize it. So having UV monitoring of potential planets that we think might be habitable is really important to just know, like, oh, this this planet is dead. It's in the right place. It's the right mass, but the star is not cooperating. And you can really only tell that in the ultraviolet. The visible wavelength flares are not. They don't. It's not like the visible flare is times 5 and the ultraviolet flare is times 500. They like don't go together. So the UV flare is really the only way to tell. And then the planets themselves, like the atmospheres, you can measure whether they have oxygen and an ozone layer, and that's all in the ultraviolet. So there's so many things. I could keep
why
going.
aren't we funding this?
Everyone bored by talking about this, but like it's just such an important wavelength range, and
Clearly.
yeah.
What type of star is more likely to give off a UV flare? Not ours.
They're smaller than ours, so like M dwarfs is the type, and that's actually where people, because they're smaller, they're easier to detect planets around, and so they're like a favorite of people looking for planets. But at the same time, if you're really looking for life, if that's actually what you care about, then they're not particularly great. And one last thing is, so if you want a planet that has life on it, and one of the things that we think is required for life on planets is a magnetic field to like protect the atmosphere.
Yep.
And a signature of magnetic field is an aurora, where like the charged particles from the star interact with the upper atmosphere. And you can measure auroras in the ultraviolet, and they're very difficult to measure in other wavelengths. So like if you had a really good UV telescope, you could be like, this planet has auroras, therefore magnetic field, therefore like a very protective little bubble, and that is like a very good candidate for maybe having life.
I think Benjamin's heard me rant ad nauseum about aurorae from work that I've done on ultra cool dwarfs in the radio, and I think certainly like complementary stuff. But why are we not funding this? Like, why is there not more collaboration between like UV astronomers and radio astronomers who are essentially studying the same phenomena, like flaring, star-planet interaction?
Do it right now.
We're gonna start now. I mean, I think that one of the challenges has been that ultraviolet astronomy does not have a ton of like extra use cases on the surface of the Earth. Like it is useful for looking at it. It is useful for looking down at the Earth. Like you can measure, like behavior of oxygen in the ionosphere and like parts of the Earth's atmosphere. And it is useful for looking out. But if you like if people develop X-ray detectors or like infrared detectors, like you put them into medical devices, you use them for like commercial applications. Like there's all sorts of stuff that are kind of valuable both from the science perspective and from like a commercial perspective. But I think the UV is the one wavelength range where people like there's not really commercial applications, and maybe we're just not creative enough. I don't know. But the result is that the only technology development is really what NASA funds, and NASA only started funding UV technology development like 15 years ago, right around when I started kind of working in the field. And there was every 10 years, the science communities do these decadal surveys where they say like, here's what a priority should be. And the 2010 decadal was like, you need to fund more UV technology. And so then NASA did, and that it's been like really transformative because now finally there are like more people interested in the UV. There's more telescopes that are getting proposed. We need all the money to follow in order to actually build those telescopes and put them up. But I think it's definitely like starting to gain a little more traction, and it's because the detectors are better, the dispersive elements are better, the mirror surfaces themselves are better. And if you can, convince people like, okay, it's a little more challenging to work in, but you'll still get a really good telescope that can do a lot of science, then that's like more interesting to people.
Is that where Aspera is going, or Aspera, or did I say it right or wrong?
So I say Aspera, and then Carlos, the PI, says Aspera, and it's actually from Latin. It's the Latin word for difficulty. And so if there's a classicist that is listening to this, like, please send me an email with how we're supposed to pronounce it.
Isn't that the thing with Latin, that no one knows how it was actually pronounced?
Maybe there's like someone who speaks ecclesiastical Latin that can tell us.
Monty Python tried to teach us Latin, and they did a bang up job. Fallen to the wayside.
Yeah. So Aspera is this small satellite that I'm the deputy PI of, and we are going to launch it next year. And it is actually really only possible because of all that technology development. Like, the detector is better, the mirror surfaces are so much better. It's like the size of a mini fridge, like a dorm room fridge, and even like 10 years ago, you could not buy a spacecraft that was that size, and I think we paid like $5 million, which is still a huge amount of money, but 10 years ago, the cheapest spacecraft was like $80 million.
Wow. So
it's totally enabled by just the fact that it's way easier to put things into space, and the cost has come down for a lot of the non-astronomical components, but then the UV components are also a lot better. So like, we have the same kind of relative observing power as a telescope that was launched in the late 90s called Fuse. And Fuse was the size of a school bus.
Mm-hmm.
It had like these big old mirrors, and Aspera is like teeny tiny, and the mirrors, the like primary mirror, is 4 by 6 centimeters. So it's just like
Centimeters.
this little guy.
Wow.
And then the flip side, of course, is like, if we can look at things for 2 weeks and just build up the photons and get a good signal to noise. And one of the downsides of Fireball, like the balloon payload, is you're up for only one night, whereas if you launch it into orbit, you can stare at something for as long as you want.
And it's launching from New Zealand on an Electron rocket, which I think is super exciting. They have
I'm
a
very
beautiful
excited.
little launch center over there. It's so pretty.
I'm going. If I think that
Are you gonna go?
I'm gonna go. Oh yeah, for sure, I'm going. And everyone on the team wants to go, so we have to figure out how we're gonna pay for it. But I was like, if I have to pay for myself, like, that's fine. I don't care. I'm going to New Zealand, and I'm gonna do a Lord of the Rings tour while I'm there, and it's gonna be awesome.
Yeah. Nice. They have the whole little Hobbit town thing there. It's all there.
Yes.
You should stop in Australia on the way. Love to see you in Sydney.
It's like a
I'm actually coming to Australia in 1 month. I'm going for like the month of October.
For IAC?
So actually, no. IAC was too expensive, and I was like, I'm not registering.
Yeah.
Yeah, it was very expensive. But no, there's a detector conference in Canberra that's the week after, and so I'm going to go out for the detector conference. And then I was like, well, I'm going all the way there, so I'm going to stay for a little bit, and I'm giving a talk in Melbourne, and then another talk in Canberra, and I'll like spend some time in Sydney. And like, I really want to go to the ocean pools that you guys have.
Yes. Ooh. We'll definitely have to talk about this offline, so I can tell you details about the ocean pools and try to get you set up with a talk in Sydney.
That'd be cool.
Yes, but we are rapidly approaching the end of this episode, unfortunately. And we have our final section, which, if you haven't listened to previous episodes, is the rapid fire round of questions and quibbles.
Okay.
So these are short soundbite answers, 11 questions.
A nice prime number of questions.
I'm ready.
Okay.
All right, Benjamin, you want to start us off?
I'll start us off, sure. What is the weirdest thing you believed as a kid?
The weirdest thing I believed as a kid? I used to think that the traffic light like red, yellow, green. I thought that it only turned yellow on some occasions. Like it was like a special time when the traffic light turned yellow. I didn't realize until I was like 25 that
Oh,
it
wow.
turns yellow every time.
That's awesome. That means you were a kid until you were 25. That's just the best answer.
I love it. Well, right, they say that the brain is fully formed at 25, so perfect.
Then I was like, now you've noticed this.
Ha!
Growing up,
I have seen
rocks.
the light, and it is yellow.
It's yellow.
Nice. All right. Next question. Which teacher had the biggest positive impact on you?
Oh, so I had a Latin teacher when I was in high school. I was like, of course, a mega nerd. And she was just like so nice and like such a human. Like I feel like sometimes you have teachers and you like can't imagine them like in the supermarket. And Joanne Mance was her name, and she was just like such a great person, and she cared so much, and you could like really tell that she cared. And I kind of felt like I like really valued that because I feel like a lot of people like they care, but they demonstrate it in ways that it's like you have to be really paying attention. But for her, it just felt like so easy for me to see how much she really cared about us. And especially because to some extent we were learning something that like it's a dead language, and except for the one kid in class who insisted on speaking Latin in class and none of us could understand him. Anyway, so she was incredible. And like she was so into Shakespeare, and like I remember after I graduated, we like tried to go to Shakespeare in the Park because I grew up in New Jersey. So, but it rained out on us. Anyway, she was awesome.
That's awesome.
Nice.
Okay. What is one scientific discovery you wish you could have witnessed in person?
Oh, I would have really loved to be on the expedition where they proved general relativity during the solar eclipse. And I'm like blanking on like who did it, and like somebody traveled really far and then it was cloudy that day, and like I feel bad for them, but I want to be with the people that actually saw the like star in the place that was predicted.
Was this in South America, and didn't Einstein was he there, or I'm not sure. I can't remember.
I don't think he was there.
Googling.
Yeah. And
I love Google's gotten
the Eddington experiment 1919. So one person went to Brazil and someone went to West Africa, and I think it was in Brazil that it was cloudy. But yeah, that I love an expedition and I love general relativity, so it's a good combo.
There you go.
Those are two awesome things. I'll open a restaurant. Those are going to be the first two things on the menu.
If you had to pick one historical scientist to go bowling with, who would it be?
I think it would be Galileo, because like he just seemed like such a cool and like difficult and like a difficult guy. He was like, I don't care that you don't want me to say all this shit. I'm gonna do it anyway. So like I really like that. But also there was this like ancient Greek, I think it was Aristarchus of Samos, I forget. But anyway, he had all these ideas like, what if the sun is the center of the solar system? He was like, the sun is really big. It makes more sense that it would be the center and not the earth would be the center. And like maybe all these little dots are just like the sun. Like he had all this stuff that he just was like, what if this was true? And he had, like, of course, had no way to prove it. So all of the text, like I don't think we even have anything that he wrote down. It's all these people writing, like talking, being like, can you believe this guy? And they like wrote that down, and that's how we know what he thought. Anyway, he seems like he'd be cool.
That's the record we have.
The record is everyone shit talking him.
The original this guy.
What a way to be remembered.
The only thing we have is like people texting about someone behind their back.
Yes, it's like that copper dealer in ancient Babylon, where like all we have are the records of people complaining about his bad copper. You guys know what I'm talking about, right?
No.
I'm not familiar with it, no.
Oh my god.
Oh my god, I'm so excited right now. I'm learning a thing. I'm
So
watching
this
a
is like
science fact happening in real
the
time.
world's oldest. It's like the oldest customer complaint. So it's this clay tablet in the. I'm looking at the Wikipedia in the ancient city of Ur about this copper merchant whose name was I Nasir, and he was a trader who was selling people like bad copper, and then someone like wrote the tablet to be like, I can't believe you sent your servant with this copper and you expect me to pay for it, like. And it's in the British Museum, and it is just like this internet joke that I really love because it's just like, oh, people are the same everywhere, and like
In all
the
time.
person is
I
like
love it.
talking about bad service and like you were mean to my servant, and it's just great.
It's been written down. This is going to get read about a lot.
Yeah.
Okay, next. If you were a sandwich, what kind of sandwich would you be?
Oh, I would be. There's this deli in New Jersey that I really like when I go back home, and they have two sandwiches, and so I would probably be the gobbler, which is their like Thanksgiving sandwich, but it's available all year round, and it's like sliced turkey with stuffing and cranberry sauce, and
Ooh.
then like a one piece of lettuce, which is completely unnecessary, and then just like the two pieces of sourdough, and it's just so good.
I love that token piece
It's
of
like
lettuce.
it is bread with bread around it. It's the best.
Oh, God, that piece of lettuce. I love it. And you leave it there, too. You take it aside, you put it aside. You know you leave it there.
Continuing the thread of really serious questions, what is your most controversial opinion about pizza?
Oh, I think that pineapple on pizza is great.
Yes.
I am like a huge fan of a Hawaiian pizza, and yeah, and I actually make pizza every Sunday. I feel like if you have the right recipe, it's really easy to make pizza.
Nice.
You have some dough in the fridge ready to go. I
Yeah.
agree. What is your favorite scientific word or phrase?
Oh, deep sea gigantism is the best. So it's this like phenomena that if so like the deep ocean is really big and it's really like nutrient poor and like dark and like extremely scary, and creatures that like live in the deep ocean, if they have if there's like a similar one that lives like close to the surface, the one in the deep ocean will always be huge. Like, and I think we don't fully understand why this process happens. If it's because like they need to live a long time in order to find another one in order to reproduce, or like something about the like mass to volume ratio. But there's a tendency of creatures that live in the deep ocean to become massive, and I like think it's so creepy, and I love it.
Wow.
That is terrifying and
It is,
fascinating.
isn't it?
Wow. I love that.
I love it. What is your least favorite scientific word or phrase?
Complicated. I don't know if that counts as a scientific phrase, but like I like
Yeah.
made a video about this because I hate it so much when people are like, "Oh, it's really complicated," and I'm like, maybe you're just bad at explaining things. Maybe you don't understand. Like, I think that it's just a way to like tell people to stop thinking, and I really hate that. So I can acknowledge that like some systems are complex, but that doesn't mean that you can't understand them.
Yeah, totally agree.
Yeah. What is your favorite useless science fact?
Favorite useless science fact. In some sense, everything about galaxies is kind of useless. I don't think
Wow.
that remain. I mean, really, it remains to be seen. But oh, that's a tough one. I feel like are any of them useless? We just haven't had enough time. I don't know. There's this French philosopher, and someone asked him in like I think the 1900s, like what he thought of the French Revolution, and he was like, "Well, that remains to be seen because like we don't know the outcome yet." And I feel like that I'm like taking a pass on answering that because I'm like we don't know what will be important in the long run.
Fair.
Nice. Cool strategy. All right. If you could rename one planet in our solar system, what would you call it?
I've never thought about this. I think I would keep them all. I love all of the planets. I would probably. I'm like coming around to the fact that I actually want Pluto to be a planet again. Um, like I actually think my definition of planet would be if it's a sphere. Is it a sphere? It's a planet. Is it not a sphere? Not a planet.
And
Not orbiting
moons.
something else. Like, is it a sphere that's not orbiting a larger body? Then it's a planet. But that might just be because I've lived in Arizona now for enough time that I've been contaminated by the like Pluto is the official state planet of Arizona.
Is it?
Because there are no
Is
plants,
it?
so they have to have a state planet.
State
Yeah.
I'm
planet.
moving to Arizona. That's it. Spring training, and they understand the
where-
Pluto thing.
It's where it was found, and like there, some of the
That's right.
members of the Arizona State Legislature are extremely pro Pluto. And the demotion of Pluto just happened like at the end of the 20th anniversary of the demotion of Pluto just happened like at the end of August.
So funny. That is
R.I.P.
great.
Pluto.
Pluto's awesome. It has a heart, literally. You gotta leave him alone.
Dude.
All right, last one. If you had to sing one karaoke song to save all of humanity from an alien invasion, what would that song be?
Born to Run, Bruce Springsteen.
Wow.
Nice.
You had that one ready.
That's my New Jersey go-to.
That and Deep Sea Gigantism. Those were just ready to jump out of her head.
I'm always singing Born to Run in my head.
I just have the
love it. Oh gosh.
I don't know why. I can't get it out.
You can like play that for the intro music for me.
Done.
Benjamin always finds these really like niche references to things that came up during the episode to start like before the cold open as an intro. And I feel like that is probably like perfect, and people will have no idea of the relevance until 56 minutes in.
I would also, if you found a song about deep sea gigantism, like I would love that.
Amazing.
Like gigantism jokes, but deep sea gigantism is going to be a bit.
That'd be
I'll
tough.
try. I'll try.
It's a tall order.
This was amazing, Erika. Thank you so much for the time, and yeah, this was a lot of fun. Actually.
Yeah, I had a lot of fun.
Fun.
I feel like in my social media videos, I try to be like silly because I want people to know that scientists can be like funny and silly, but actually like it's also just because that's how I am. I can't like be any other way. I'm very unserious.
Well, yeah.
I'm very with you on that, and I have like tried my hand at science comedy, which is super difficult.
Oh, I bet.
It has made it even harder for me to not be a silly Susan while I give actual science talks.
I think if you can make like a colloquium audience laugh, then you are doing great. It's always my goal is to get them to laugh.
We will have to test that when you come to Australia.
All right. Deal.
Awesome.
Amazing.
All right,
where can people find you on the interwebs?
You can find me on Instagram, TikTok. Sometimes I post on LinkedIn, but LinkedIn is lame. And so
immediately requesting you on LinkedIn. Okay, got
yes,
it.
connect with me on LinkedIn, you guys. And you can buy my book, Weird Universe, wherever books are sold. Buy it for your dad for Christmas. It's a great present. Or your mom who wants to learn about space. Or yourself.
I love it.
Have you managed to like finish reading it in the week already since you got it?
I have like 3 chapters left to go. You can tell
Wow.
by the thickness of my post-it notes. I have so many
That's
things.
awesome.
Stars are never green. Come on.
No.
That's
Stupid
going up on
human
science.
brains getting in the way.
Oh,
damn that. And Benjamin, where can the good people find you and
Please,
or our episodes?
You can find me under the name Science Actually. The big one's on Facebook, and you can also see it on Instagram. and TikTok and YouTube are daily science facts, daily collective nouns, and lots of science articles. You'll see every single science article that I read, mostly. I'm sharing it. And also, if you want to watch the show, if you want to listen to the show, please go to TikTok or YouTube or wherever you listen to your podcasts. And how about you, Mr. Kavi?
Folks can find me at Fun Fact Science on all the good social media platforms and also the bad ones. We would love to get listener and viewer feedback on any of these episodes, ideas for new episodes, and we've also recently posted a link on the socials if you would like to suggest or volunteer yourself as a guest on future episodes. Thank you all for watching and listening, and we'll see you next time on the next episode of Science Actually Presents The Nerd and the Scientist.